Have you ever stopped to wonder how a model like GPT-4 actually reads your prompts? I mean, really reads them. Because it definitely doesn't see words the way you and I do. Well, today we're going to break down the fascinating process of tokenization. It's the absolutely essential first step that turns our language into something an AI can actually work with.
So here's what we've got on tap. We're going to start with the fundamental reading problem that AI has. Then look at how we get from bits to bytes. Then cover the smart merging technique called BPE. After that, we'll see it all in action and wrap up with why any of this really matters. Let's dive in.
All right, first up, the AI's reading problem. You can really think of this as a massive translation issue. How do you bridge the gap between our rich, nuanced human text and the super rigid logic of computer code?
This is the big question, right? When you type something into a chat window, what does the neural network actually see? It's not the letters, and it's not even the words. The reality is, well, it's a lot weirder and a lot more structured than you might think.
See, here's the fundamental rule. Neural networks can't just handle the infinite, beautiful mess that is human language. They need something clean. They need a straight, one-dimensional line of symbols that come from a very specific, limited menu, kind of like a fixed vocabulary list.
And wow, this slide really just lays the problem bare. On the left, you've got a simple hello. On the right, that's what a computer sees at the most basic level. It's the UTF-8 binary code for that word. And just look at how absurdly long that sequence of zeros and ones is for just one word.
And that length, that is a gigantic problem. You have to understand, in the world of AI, sequence length is like your computer's memory or its processing power. It's an incredibly precious resource you can't waste. Trying to feed it this massive string of just two symbols, 0 and 1, is just unbelievably inefficient. We've got to find a better way.
So how do we start to fix this mess? Well, the very first step is to stop thinking in individual bits and start using a much smarter grouping, bytes.
The logic here is actually super simple. You take that ridiculously long stream of bits, you just chop it up into neat little groups of 8, and each of those groups becomes a single new unit. We call it a byte. This is our first real step toward compressing this information.
And what does that get us? Well, when you have groups of 8 zeros and ones, there are exactly 256 possible unique combinations. So all of a sudden, our vocabulary isn't just two symbols anymore, it's 256. And I love this analogy. Don't think of these bytes as the number 0 through 255. A much better way to picture it is to imagine we now have 256 unique emojis. So our text isn't a long string of bits anymore. It's a sequence of these cool little emojis. It's a way richer and much more compact way to represent everything.
So you see the trade-off we're making here, right? By grouping our bits into bytes, our sequence length instantly gets 8 times shorter, which is amazing. And the only price we pay is having a bigger vocabulary to deal with. 256 symbols instead of 2. That is a fantastic deal. It's a much more efficient place to start. But you know what? We can do even better. And this brings us to where the real magic happens in modern tokenization. An algorithm called byte pair encoding, or BPE. This is how we build a truly custom, powerful vocabulary for an AI.
At its heart, BPE is a really clever compression algorithm. Its whole job is to scan through a massive amount of text, find pairs of symbols that show up together all the time, and then just merge them into a brand new single symbol.
And it just does this over and over and over again. So for example, it might notice that the bytes for T and H are constantly next to each other in English text. So the algorithm says, okay, I'm going to create a new symbol, number 257, and that symbol is just going to mean TH. Then it zips through the whole text, replaces every single TH pair with this new symbol, and starts the process all over again, looking for the next most common pair. So after you run this merging process thousands and thousands of times on a giant data set, what do you end up with? You get the vocabulary for a model like GPT-4. It has precisely 100,277 of these unique symbols or tokens, and that's the powerful result of all that intelligent merging.
Okay, so that's all the theory, but what does this actually look like in the real world? Let's make this way more concrete and actually look at some tokens in action.
All right, let's take the classic example, hello world. How does the GPT-4 tokenizer actually see this phrase?
Well, it breaks it into exactly 2 tokens. Token number 1 is hello, and it gets its own unique ID. And this is super important, look closely at that second token. It's not just world, it's world. The space is actually part of the token. Why? because the pair, space, then world, is so incredibly common in English that the BPE algorithm decided it was more efficient to just merge them into a single token.
Now, what do you think happens if we make one tiny little change and just get rid of that space?
And boom, this is where it all clicks. Without that single space, the word just shatters into pieces. Instead of 2 clean tokens, you might get 3 or 4 totally different ones, like hello, whoa, and world. And that proves it, right? Tokenization isn't about neatly chopping up words. It's all about the statistical patterns the algorithm learned from the data, right down to the individual spaces and punctuation.
So let's zoom out and bring this all home. Why did we just go through all this trouble with bits and bytes and all this clever merging? Why does tokenization actually matter so much? So when we say tokenization, we're really talking about this whole journey we've just been on, from our messy human text down to the bits, up to the bytes, and finally to these smart, custom-made tokens. It's all the essential prep work that has to happen to turn our language into a sequence an AI can finally process.
And that's really what it's all about. Tokenization is the translator. It is the essential bridge that connects our messy, beautiful, chaotic world of language to the cold, hard, mathematical world of vectors and numbers where AI actually lives. It's that simple. Without this bridge, there is no ChatGPT.
And all this leaves us with a really fascinating, kind of mind-bending final thought. If an AI never actually sees words or sentences, but just a long sequence of these numerical IDs, what does it even mean for it to understand language? It's a question that gets right to the very heart of what these systems are and what they're becoming. Something to chew on. Thanks for joining me.